Hello, good day, or good morning. No morning. Good day. We are living in very interesting times. COVID-19, the virus is all over the place. It's in the news, it's everywhere. It's changed our lifestyle, and things are not, will never be the same again. So now we don't hug, we don't handshake, but one thing remains the same that we need to really, recognize that there are certain things that are beyond us as human beings, and we need to give glory to God for keeping us. In fact, because you can imagine Ghana. I don't want to go into the politics and everything. We don't have a lot of time. The little bandwidth I have, I want to make good use of it. So let's look at of that. Why we need databases. How do we want to actually, create a database itself? Database management systems, the software does the job, all objects. But then the most appropriate way to do it is to use spatial database systems. And we came to the point of even recognizing that relational database theorem is very important to know, even though, like, the current trends are towards non-relational tables that have not been, normalized and things like that. And so, of course, we understand the word normalization. We talked about that. And we said that if a table is normalized, then it should have gone through three or four steps or stages. And these are the first normal forms, second normal forms, third normal forms, and then we can even talk about the boys code normal form. Okay, so we have actually dealt with functional dependencies, which has helped us. We wanted to avoid update anomaly, deletion anomaly, and insertion anomaly. Are you okay? If I insert one record and it creates a certain problem, right, then I'll have to look at the table again. Okay, because maybe the table isn't good enough. And that is why we do normalization to make sure that we break up our table and then on query they get joined up again. That's what we said from our previous lecture. So the boys code normal form was like the last one. We said that, well, most tables in third normal forms, which have actually obeyed, not allowed partial dependencies, okay, and avoided transitive dependencies, etc. And of course, the prime key appreciate what relational algebra is about, okay. All right. So it's very simply we need to find a way to query a database, and that is the structured query language. Are you okay? So query languages are very important. All right. So we do search through, we query databases, but we need to have behind our mind relational algebra. Why? Because we're trying to extract data, but it has to be in a very logical way. Are you okay? Has been a very logical way. And because tables have been broken down, or if you like relations into relations, yeah, databases, relations, yeah, that link is very important to recognize that. So we need to appreciate what relational algebra is. Relational algebra is a query language. Okay. So relational algebra is what a query language, all right, which takes instances of relations as input and yields instances of relations as output. Okay, so it uses operators to perform the queries. In other words, we are talking about algebra is really what's algebra about? Ax equal to y. That is algebra. So relational algebra is saying that we need operations and we need some tree in the table, a building in the table. Okay, which particular one? The one with the lowest cost, things like that. This is what we will be simply failed to parts, two things, and you can have one that works on one. All right, and we say that they accept relations as their inputs and yield relations as their output. As I was telling you, you need an operator, and an operator will take something like maths. If you're doing maths and you want to operate, okay, mathematical operations always require you to do what? To have two numbers and then you have the operator sitting in the middle. So 2 times 2, for example. All right. So the operator is the multiplication sign, and then we have the other parts of it. Are you okay? All right. As the inputs, what's the inputs? Maybe 2 and 3, and then the operator in the middle. This is the same concept. So here, what are our operators and operations that we want to take? Is that okay? All right. So we want to talk about the fundamental operations of relational algebra. And the fundamentals are as follows. We have the select operation, the project operation, the union operation, the set difference operation, the Cartesian product. We can even have the rename operation. All right. So these operations are used on relations. So what are you thinking about relations? I told you that when you think about relations, think about tables. Think about relations, think about tables, but think about tables when you have actually finished building and designing your database. And think about relations when you are in the process of a kind of concept, thinking about it in concept. There's no data in it, but a table exists. Are we okay? It's like the design. So relations are our inputs, and then the operators are this, for example, the select operator. So let's look at the select operator. So with the select operator, we have a symbol that we want to actually use, select operation. What do we mean by select operation? So if we have relations and we have a select operation, what does it do to the relation? It's like, think about if you have a table and you want to do a select, what does it do? All right. So what it does is very simple. I think we all know what it does. It selects. Select operation will select. It selects tuples. What are tuples? Think about tuples as rows. Okay? Think about tuples as rows. So it selects tuples that select the given predicate from a relation. So because I'm using Microsoft Word, let's look for synonym of a predicate. So we're looking at a base. Are you okay? The center. So a given predicate, but predicates are used really in grammar and English. You know, when you are being taught English and all that, the word subject and predicate, you remember that? Okay, so here we have subject and predicate being used in database, you know, in the field of databases. So the notation is this, all right, that we want to actually select based on the predicate a certain relation. So please let me go over it again. We want to select a certain predicate based on a certain predicate, all right, a certain relation from a certain relation, all right, select from a relation based on a certain what predicate, certain. What are we selecting? We are selecting tuples. What are we selecting? Tuples, and tuples are rows, rows. So rows, yeah. Let me spell rows for you. Oh, I thought I had my notepad here. So let me do a window capture and get my notepad showing here. Just hold on a second. I just want to type the word rose so that you are not thinking about red roses, pink roses. Are you okay? White roses. Okay. So that's funny. Um, okay. This is asking me to create a text. Okay. So I'm referring to rows. Okay. So when we say tuples, oh, it is synonymous. Okay, all right. So let's go back the select operation. This is how it works. So let's do, I think we will show an example, but let's look at it closely. So this symbol, what's it? How do you pronounce this symbol? Tor or something like that. So this symbol here, this is not Tor. It's looking more like it's a Greek symbol. I don't want to waste your time on it. We can go and look at it. It doesn't matter. Draw it to look just like that, and you'll be okay. This is not your Greek class. So that symbol that we are looking at, okay, stands for selection predicate. The selection predicate. And R stands for the relation. And P is a prepositional logic formula. Prepositional logic formula, which may use connectors like and, or, and not. Okay, so now those who have done computer programming before, remember that these are logical operators. Okay, so our selection predicate hmm, combines with our prepositional logic formula. So what is the logic? I want to select something from here, but what's the logic? I want to select only I want to talk about girls today. It is a birthday of my sweetheart. Okay, let me talk about it. Anyway, so prepositional logic, yeah, is a P, R is a relation. Let's go. And then we are done. These terms may use relational operators like equal to, less than. So there's a whole lot that we can do. Okay, so for example, if you are dealing with integers, I want to find out, okay, all those who are having an average salary of or salary of you see that bank account balance of 2,000. Okay, and that doesn't include me. Okay, so pay up for your handout. Okay, so we could be using these operators here, less than, greater than. Excuse me, throat is dry, got nothing to do with COVID, you're safe. All right, so we have an example here. If what I'm saying doesn't make. Hello, good day, good morning. Oh, yeah, no morning. Good day. We are living in very interesting times. COVID-19, a virus is all over the place. The news is everywhere. It's changed our lifestyle, and things are not, well, will never be the same again. So now we don't hug, we don't handshake. But one thing remains the same, that we need to really, recognize that there are certain things that are beyond us as human beings, and we need to give glory to God. Interesting times. COVID-19, a virus is all over the place. In the news, it's everywhere. It's changed our lifestyle, and things are not, will never be the same again. So now we don't hug, we don't handshake. But one thing remains the same, that we need to really, recognize that there are certain things that are beyond us as human beings, and we need to give glory to God. Hello, good day, good morning. Oh, yeah, no morning. Good day. We are living in very